It is hard to talk about thermochemistry without talking about an exothermic process and an endothermic process. In an exothermic process, heat is released or lost by our system. In an endothermic process, heat is gained by the system. The convention is also to say that in an exothermic process, Q is negative, as heat is lost, and in an endothermic process, Q is positive, as heat is gained. So here we have an ice cube in a glass of juice, and let's make the ice cube our system. Is this now an endothermic process or an exothermic process? So what is happening? Q, heat, is being transferred from the juice into the ice cube, and as a result, the ice cube is gaining heat, and it will eventually melt. So because the ice cube is gaining heat, it is an endothermic process. And we could write that ice plus heat will give water. Let's make our water in this kettle the system. So we're going to heat it up. So I put the kettle on a stove, and as a result, heat is being transferred from the stove into the water. So once again, heat is being gained by our system, that is water in this case. Therefore, this is an endothermic process. And we could write that I have started with cold water, and I have added heat, and as a result, I've got hot water. Let's look at another example. Let's say I go for a run, and I pull a muscle or injure myself somehow, come back home, I stumble home, and I decide to apply a heat pack. So here's my heat pack, and a heat pack contains really two bags, one inside another. The outer bag has water, while the inner bag has salt. Once the two are combined, heat is being released by the system. In this case, our system is the reaction between the water and the salt. And because heat is being released or lost by the system, this will be an exothermic process. And we could write down that I have water to start with, plus some salt. And once they mix, I end up with salty water and heat. So note that in an endothermic process, heat appears on the left-hand side of the equation as a reactant, while in an exothermic process, heat, which is now released or lost, appears on the right-hand side of the equation as a product. So how does this relate to enthalpy? Well, recall that the change in enthalpy, so delta H, is equal to Q. For an exothermic process, delta H will be negative Q. And as a result, we can say that the delta H for an exothermic process is negative. On the other hand, if we look at an endothermic process, Q will be positive. And as a result, we can say that the change in enthalpy is positive. So to summarize quickly, in an exothermic process, Q is lost, and as a result, delta H is negative. In an endothermic process, Q or heat is gained, and as a result, delta H or the change in enthalpy is positive.